Welcome back to my YouTube channel, and today we will study for chemistry, the chapter environmental chemistry for IIT JEE NEET. Okay, so let's start with environmental chemistry. Our environment, because of pollution, our environment is getting spoiled, it's getting damaged. So how can we protect our environment? What are the reasons it's getting polluted, etc. We will learn now. So first we will start with the topic atmosphere. There are so many layers in atmosphere, but in NCRT we'll have about two layers, that is troposphere and stratosphere. So Earth's important layers are, if we go above the sea level of Earth of 10 kilometers, it will be troposphere, which will have gases like oxygen, carbon dioxide, nitrogen. If you go 50 kilometers above, you will have stratosphere, which will contain ozone. Ozone layer will be present. Okay. Now, first we'll start with air pollution. Air pollution will have tropospheric pollution and stratospheric pollution. So, troposphere pollution, it is caused because of industry smoke, aeroplane gases, automobiles, industries, ACs, fridge, all those gases. First, we will study about sulfur dioxide. It is a harmful gas present in all these, which results in danger. These two reactions are very important. 2SO2 plus O2 gives you 2SO3, and when 2SO3 plus H2O gives rise to H2SO4, sulfuric acid. This results into respiratory illness and increased greenhouse gases, these reactions. Second, you will have nitrogen. So N2 plus O2 gives you 2NO, plus 2NO plus O2 gives you 2NO2. So nitrogen only reacts when there is strong striking clouds. When there is a strong striking in clouds, then these reactions will take place. You need to remember these reactions. And if in place of oxygen, here you can see oxygen, if in place of oxygen, if there is O3, then the formation of NO2 will be faster. So 2NO plus O3 gives you 2NO2, but it will be faster when compared to oxygen. Now, NO2 is also produced by jet planes. While striking, lightning also it will cause, and it will be produced by jet planes also. This is the second gas in tropospheric pollution. Our next is gasoline or petrol. These have hydrocarbons called carcinogenic. They cause carcinogenic problems like cancer. It will cause cancer. When petrol gets incomplete combustion, then the smoke coming out of cars is called unburned fuel. That fuel which will come out of the vehicles, which is unburned, that is very harmful for our air, for our atmosphere. It is called unburned fuel because it is incomplete combustion takes place. Then the next is carbon monoxide, CO. That is also very dangerous because it is one of the deadliest gas. Combustion in limited or less oxygen results into formation of carbon monoxide. It is colorless and odorless. If suppose carbon monoxide is getting released, you cannot even feel, you cannot even smell, you cannot even see it. It is released by generators, geysers, heaters. Okay, old geysers, old heaters, those will generate carbon monoxide. And when it joins with hemoglobin, it will cause death or serious brain. If you don't cause death, it will give you serious brain disorders. And when it joins with hemoglobin, it is known as carboxyhemoglobin. Then the next gas is carbon dioxide. Carbon dioxide is important. It is important, like if we release carbon dioxide for plants, it's very important to prepare the food, etc. for photosynthesis. But excess is bad for environment and increases greenhouse effects. Then hydrogen sulfide is also another gas, okay, which is harmful for our atmosphere. Now coming to topic global warming. Global warming, sun gives radiations, UV radiations will be given by sun to our earth surface. But this ozone which is present in stratosphere, that will not allow those UV rays to come inside the earth. But now, because of this pollutions, ozone layer is having holes. Because of that, all the UV radiations are coming inside the earth and they are causing irritation, cancers, etc. So let's give a reading. Sun gives radiations which are stopped by ozone layer in atmosphere, but now ozone getting holes, so these come in. If they wanna go back, they cannot go back. They cannot go back if these radiations wanna go back. They cannot go back because of greenhouse effect, greenhouse gases. They are not letting it go back. they are covering the earth with a layer which is not letting those radiations go back into the into the space, which results into huge amount of heat. So in that means that we are trapping heat. Earth is trapping heat inside, and slowly that will increase heat on the earth. So what are greenhouse gases? Examples are carbon dioxide, methane, water in steam form, chlorofluorocarbons, nitrous oxide, ozone, etc. These are greenhouse gases. Ozone, you may be saying that ozone stops these radiations. No, when ozone should be in stratosphere, but when it is in troposphere, it is bad for us. It should be, it should be above than 10 kilometers from the sea level. If it is in troposphere, then it will be bad for us. Okay, ozone. It should be in stratosphere. Now coming to the topic acid rain. Acid rain, mostly these two reactions take place. H2O plus CO2 will give you H2SCO3, carbonic acid. Okay, but if it results into sulfuric acid or it results into nitric acid, you think yourself, if sulfuric acid and nitric acid is falling on you, what will happen? So this equation 3 and equation 2 is very dangerous for us. Acid rain, that is not that dangerous as. Now we'll see about particulate matter. There are 4 types of particulate matter which we'll study: smoke, dust, mist, and fumes. Mist is nothing but moisture air. Smoke, dust, they will settle down, but again if wind comes they'll flow, and again they will settle down. Okay. So let's start about smog. What is smog? Smog is nothing but smoke plus fog will give you smog, and there are 2 types of smog: classical smog and photochemical smog. Okay, classical smog is also known as reducing smog, and photochemical smog is known as oxidizing smog. Classical smog you can remember by C and C. With class C you have classical, with C you have cold. So classical smog will form in cold, humid conditions, whereas photochemical will form in warm, dry, sunny conditions. Okay, and classical smoke plus fog plus sulfur dioxide, SO2. You need to remember this: smoke plus fog plus SO2, whereas this is formed by sunlight and nitrogen dioxide. This is NO2 and this is SO2. Photochemical: action of sunlight on unsaturated hydrocarbons and nitrogen oxides will give you photochemical. Now let us start about photochemical smog. So photochemical smog is formed when NO2 in presence of sunlight, it will split into nitrogen oxide and plus oxygen. Okay, this is not oxygen, this is not O2, this is only O. When O plus O2 gives you O3, and then again when this nitrogen oxide plus O3, it will give you NO2 plus O2. Then you need to remember that this is very important. This reaction 3CH4 plus 2O3 gives you 3CH2 double bond O plus 3H2O plus CH2 double bond CH2 CHO plus CH3C triple O NO2. So C3H3CH4 is unburnt hydrocarbon. Okay, this CH2 double bond O is nothing but formaldehyde, which is also known as, common name is methanol, and CH2, this compound is known as acrylaldehyde or acrolein, and this compound is known as peroxyacetyl nitrate, which is PA in pan. You will have another pan also, but here we have this peroxyacetyl nitrate. Don't get confused between these 2 pans. Okay, what are the disadvantages of unburnt hydrocarbons? This will cause cancer. This is carcinogenic. Whenever the word carcinogenic comes, it means it causes cancer. Then it is harmful for plants by causing aging, breakdown of tissues, shedding of leaves, flowers, twigs. Okay, unburnt hydrocarbons have these disadvantages. Whereas formaldehyde, which is having common name as methanol, it is a colorless gas. It has pungent smelling, and its boiling point is minus 19 degrees Celsius. Remember, it's soluble in water and acetone, and it causes irritation of skin, eyes, nose, throat, and if you have high exposure, then you have cancers. Okay, that is the disadvantage. That is why this photochemical smog is dangerous for us. Till now, what we learned about those gases, etc., that won't come, but mostly this will come. This smoke plus fog, what kind of smogs you have two kinds of, and then again explanation and the photochemical smogs reactions. Again about formaldehyde formation of these names, you need to remember these three names. This is very important. That will come in NEET and JEE, remember. So till now we studied about troposphere. Now we'll study about stratospheric pollution. Stratospheric pollution, formation of breakdown of ozone. Okay, that is nothing but formation of breakdown of ozone is nothing but which is dangerous for us. When it forms, see, O2 plus O in presence of ultraviolet rays gives you this O3, which is okay, good, it's good. Like in stratosphere, you should have ozone. It's okay. We have it is important. But if it is getting depleted, like if O3 is giving back these two compounds, O plus oxygen, that is harmful for us. Okay, ozone depletion will leads to free radicals, which is dangerous for us, like CF2Cl2, which is also known as chlorofluorocarbons or freons. In presence of UV, give you free radical for chlorine, free radical of carbon. Okay, it gives you radicals, free radicals, which is dangerous for us. And here also you can see ozone is getting depleted. We don't need oxygen in stratosphere. We just need it in troposphere. But here it's forming oxygen. Here also it's forming oxygen, which is known as depletion of ozone. Here it was forming ozone, that is good for our stratosphere. But depletion of ozone is not good for our stratosphere. That causes stratospheric pollution. Now, you may say here oxygen is forming, which is good. But no, it's not good. It's forming in stratosphere. And it is killing ozone, which has to be present in stratosphere. Oxygen is killing that and it is forming, which doesn't has to form in the stratosphere. Okay, you should understand this concept. So it should be in troposphere and nowhere else. When ozone won't be there in stratosphere, how will we survive when ozone won't be there in the stratosphere? All the UV rays will come inside. So if this oxygen, when it is getting formed, it's killing this ozone. That is very harmful for us. Okay, are you getting this point? How is it causing this stratospheric pollution? Coming to the topic, water pollution. Water pollution is caused by industrial waste, garbage, drainage, dumping. Pathogens present in human excreta, like you should remember this, all this excreta and all, it's going into the it's going into the oceans, it's going into the seas, which is spoiling it. You see people, this all the drainage system, it's not proper for the oil or the slum areas. Or if you go and see there, you can see that people do it everything in that water only. They don't keep it clean. They do everything in that water and they drink that water. Even we are drinking that water. Okay, so pathogens present in a human excreta will pollute the water. Then polychlorinated biphenyls, you need to remember this, PCBs, polychlorinated biphenyls. These are cleansing agent and causes carcinogenic problems. Again, what? Cancer. And this is drainage dumping is also there in water. We all dump everything. We have dustbins to dump different kinds of wastages, but again we'll dump in the water sources only. Excessive phytoplanktons. If you go for organic waste dumping is also not good. Biodegradable waste. Excessive phytoplankton growth is also not good for our water. Now eutrophication, decrease in concentration of oxygen in water due to pollutants. Decrease in concentration of oxygen in water due to pollutants is nothing but eutrophication. Now, international standards for drinking water. Water is tested for fluoride ions concentration. Fluoride deficiency is harmful for our tooth decay. Is harmful for us and will cause tooth decay. Soluble fluoride often added to drinking water to bring its concentration up to 1 ppm or 1 milligram. Okay, so ppm is nothing but parts per million. So fluoride ion is very important for us. Okay, that is why water will be tested for fluoride ion concentration. soil pollution because of heavy metals. We just use those batteries of our phones, of the shells, and then we throw it in the soil. That causes problem in soil. That causes soil pollution, heavy metals. Okay, just remember this diagram. And then pesticides like DDT, dichlorodiphenyl trichloroethane, that is also not good. In olden days, people used to use those cow dungs, etc., for manure. But nowadays, they think that applying this DDT, etc., will give good growth to the plants. But it's not. It's spoiling. It's spoiling the soil. The soil is losing its growing capacity. Now, herbicides like sodium chlorate, sodium arsenite. Just remember this formula: sodium chlorate, NaClO3, NaClO3, and sodium arsenite, Na3ASO3. These are herbicides. Coming to chemical pollutants, metals like cadmium, mercury, nickel are dangerous to humans because our body can't excrete them. This causes damages to kidneys, central nervous system, CNS, livers, etc. Liver, actually, not livers. Livers. Okay, liver. Then acids like sulfuric acid H2SO4 from mine drainage, and salts from different sources like raw salt used to melt snow and ice in cooler climates are water soluble pollutants. These are water soluble pollutants, sodium and calcium chlorides. So these are used for melting the snow and ice in cooler climates, H2SO4, etc. Agricultural waste produced from the agriculture, medical waste produced from all the hospitals, etc., and mining waste from the mines and industry. To green chemistry is nothing but use of chemicals for pollution prevention by proper designing of chemical products and processes that reduce use of or that reduces generation of hazardous substances. Okay, so using of chemistry. So this is chemistry. Use of chemistry for pollution prevention. Okay, that is why we use green chemistry. It consists of green solvents, green catalyst, green and renewable raw materials, efficient processes. It is environmental friendly. So we can use in dry cleaning. Say suppose example is given as dry cleaning. So in dry cleaning, in olden days we used to use tetrachloroethane. You can see the structure Cl2C, Cl2C, double one CCl2. This is tetrachloroethane. We used to use this in olden days. This is now replaced by H2O2 for bleaching of clothes. That is nothing but green chemistry. Clear? Thank you. These points as the last points. Okay, carbon monoxide binds to hemoglobin to form carboxyhemoglobin, HbCO, which is about 300 times more stable than oxyhemoglobin complex, that is HbO2. 300 times. Remember this numerical. Okay. Now, the oxygen deficiency results in headache, weak eyesight, nervousness, cardiovascular diseases, etc. Carbon dioxide also emits during volcanic eruptions. It also forms by decomposition of limestones during manufacture of cement. Remember this reaction CaCO3 in presence of heat. While heating, it gives CaO plus CO2, formation of carbon dioxide. Then carbon dioxide has to be present only in troposphere, not in stratosphere, etc. Increased amount of carbon dioxide results in global warming. It's good. Carbon dioxide is good for atmosphere, but increased amount will cause global warming. So answer these questions. Among following, which is not a greenhouse gas? Sulfur dioxide, nitrous oxide, methane, ozone. All are greenhouse gas except SO2. If you observe questions from like not, which gives in the question not, these are mainly given in your NEET exams, and only one question will be given from this environmental chemistry. Which oxide of nitrogen is not a common pollutant introduced into atmosphere both due to natural and human activity? We saw N2O, we saw NO2, we saw nitrous oxide, we saw nitrogen dioxide, we have nitrogen oxide, but we didn't see N2O5. So it is N2O5. Which of the following is a sink for carbon monoxide? Microorganisms in soil, oceans, plants, hemoglobin. It is microorganisms in soil. And now you need to remember, in cold water, dissolved oxygen. They don't give it sometimes, they don't give you dissolved oxygen. They give you abbreviation like DO. So you need to remember or they can ask you the full form for DO, that is dissolved oxygen. So in cold water, dissolved oxygen can reach a concentration up to 10 per parts per million ppm, whereas oxygen in air is about 200,000 parts per million. If concentration of dissolved oxygen of water is below 6 ppm, growth of fish gets inhibited, means aquatic life will get affected if the concentration of dissolved oxygen DO of water is below 6 ppm. Amount of oxygen required by bacteria to break organic matter present in certain volume of water is called biochemical oxidation demand, BOD. That is something but amount of oxygen which is required by the bacteria to break organic matter which is present in certain volume of water. Clean water is less than 5 ppm. Highly polluted, it is greater than or equal to 17 ppm. Okay. So pollutant, if suppose pollutant is given as radioactive substances, then the source is from like mining of uranium containing minerals. Okay, remember this.